This lesson is on theorems for similar triangles. The essential question for this lesson is, what are two theorems that can be used to prove that triangles are similar? As you might remember, the last lesson we learned that there is a postulate called the angle similarity postulate, where if you have two angles of one triangle congruent to two angles of another triangle, then the two triangles are similar. Well, in this lesson, we're going to learn about two theorems, which can also be used to prove triangles similar. The first theorem is Theorem 7-1. It is the Sas Similarity Theorem. Now, the wording of this theorem is, if an angle of one triangle is congruent to an angle of another triangle, and the sides including these angles are in proportion, then the triangles are similar. Hence the term SAS, okay? So basically you've got congruent angles, and the sides that make up that angle are in proportion, okay? And that's how we can prove triangles similar. I'll give you an example here shortly. So here are two triangles that are similar, ABC and KLM. Note the angle B is congruent to angle L. And also note that side AB divided by side KL is equal to 3/2, and side BC over side LM is also equal to 3/2. So therefore, this is an example of two triangles being similar by SAS. The angles are congruent, and the sides that make up those angles are proportional, or are in proportion. The next theorem is Theorem 7-2, which is the Sas Similarity Theorem. And the wording of this theorem says, if the sides of two triangles are in proportion, then the triangles are similar. So what they're saying here is that all three corresponding sides have to be in proportion, then the triangles are similar. So here's another example. I've got a triangle KLM and another triangle RQP, okay? And if these triangles truly are similar, then we should be able to see that the sides are in proportion. Now, if we look at the corresponding sides and their ratios, we see that Km over Rp is 10/12, which is 5/6. Ml over PQ is 15/18, which is 5/6. And Kl over Rq is 20/24, which is also 5/6. So therefore, these two triangles are indeed similar by SSS. Now, I would like you to consider two triangles, ABC and XYZ. The measures of the sides of triangle ABC are 4, 5, and 7. So that's 4, 5, and 7. And the measures of the sides of triangle XYZ are 16, 20, and 28. That's 16, 20, and 28. I want to know, are the two triangles similar? And if they are, well, whether they are or they aren't, I would like to indicate your answer in the drop box, okay? So that's triangle ABC with sides 4, 5, and 7, and triangle XYZ with sides 16, 20, and 28. Are they similar? And put your answer in the drop box.